Right, so now let's have a look at periodic functions. So what is a periodic function? So according to the definition, periodic function is a function that repeats itself on a regular interval. So this is the definition. And the regular interval has a specific name. It is actually known as being the period, and it is denoted by capital T. So in the Fourier series later, whenever you come across something that is a formula defined by capital T, so it actually represents by the value of the period. Right, so what happened is that, so let me show you an example of a periodic function. So how does periodic function looks like? This is going to be one of the examples. Okay, let's see if I have something like this. So this is going to be my function. It looks like this. So this is just a sketching, so it roughly looks like that. And let's say I'm going to put a scale over here. Let's say it's going to be -1, this is going to be 1, and this is going to be 3, and this is going to be 5. If you notice, so basically a periodic function is a function that has the same shape being repeated over and over again. So that is actually the characteristic of a periodic function. If you notice, that is a similar shape over here. So this is the primary shape. It's just a triangle. And how many triangles do I have here? I have one. This is the first one. This is the second one. This is the third one. And each of the triangle over here, so each of this is known as being one cycle. This is one cycle. So this is going to be the second cycle, and this is going to be the third cycle. Right? So each complete shape of the function is going to be known as a cycle. Alright, so what happened is that, now let's talk about the period. So period is actually defined, so let me put a remark over here. Period is distance of one complete cycle. Okay, so bear in mind it is going to be the distance. So for example, if we were to referring to this case, what happened is that this is my one cycle from -1 until 1. So this is being defined as one cycle. So what is the distance from -1 until 1? So from here to here, that is a distance of 2 units. So that is why when I write down the period value, so t is going to equal 2 units. And if you remember the definition, the features is that it is a function that repeats itself on a regular interval, meaning that for each of the cycle, it is going to repeat itself every 2 units distance. So the first cycle is going to be in 2 units distance. Second cycle should also be in the same period value unit distance, and the third cycle is also going to be in the same distance value, which is going to equal 2. So it's going to be the same for each of the period. Okay, let me show you another example. So, or if I would have something like this. Okay, so this is also going to be an example of a periodic function. So let's put a value over here. Let's suppose it's going to be -pi until pi. So this is going to be 2 pi, and this is going to equal 3 pi. So if you have a look, what is the primary shape? So the primary shape is going to be this. It's sort of like look like an S with a curve. All right. And for this case over here, it is also a periodic function because we have the same function being repeated over and over again. So what is going to be the period? So the period is going to be the distance of one complete cycle, and for this case we have 2 cycles, and each of them are going to have a period of 2 pi, because the distance from -pi to pi, that is equal to pi, and the distance from pi under 3 pi, so that is going to equal 2 pi. So the period is always going to be the same for each of the cycle, no matter where the position is. Okay, so in this particular topic, you have to know how to sketch for periodic function. What is the reason for being able to sketch for periodic function? Because we wanted to be able to identify whether the function is even, odd, or neither in order to do our calculation in Fourier series. So let me refresh you a little bit on the case of even, odd, and neither, in case you forget them already. So remember, an even function is when you have your function being put together side by side. Alright, so it's going to be a mirror image of each other side by side. Odd function, the features is that you're going to have one line at the bottom, one line at the top, and the lines are supposed to be symmetrical to each other. And it's going to call as being neither if it doesn't show the possibility of being odd or being even. Okay, so here this example previously, remember when you have an even function, it always going to be side by side, and even this one I show you the case of cos, so it is also being positioned side by side. So where do you want to have a look at position, whether it's going to be side by side or not? So you will look at the axis itself, right? So this is our axis, so you identify the function two lines that is being separated by axis, whether they are being side by side or one at the top or one at the bottom or being neither. So going back to what we have seen previously, for example this one, so this is going to be my axis. So when you want it to determine, you have to determine by observing the lines that is positioned side by side being separated by the axis. And for this case, you have two lines that are symmetrical. It's supposed to be symmetrical, but my drawing is just a sketching, so it might not look like so. So that is why for this case over here, we can identify right away that this is going to be an even function. So because they are side by side. And for the second example, so this is going to be my axis, right? So I'm going to observe the two lines, which is position, which is separated by the axis. So one is at the top, one is at the bottom. And even like, remember for the case of odd function, I have to reflect that twice. If I had to reflect that first on the horizontal axis, so referring to this one, so this is how the line is going to look like. And when I reflect that again on the vertical axis, which is this axis right here, then only it will become the shape separated by the axis. Okay, and when we have to reflect twice in order to get the other curve, automatically this is going to be defined as being an odd function. So that is what you want to do. You're going to sketch the graph and you're going to identify whether it's going to be odd, even or neither. Then only you can start with the calculation. So that is why if your sketching is wrong, that you identify it wrongly, if it's supposed to be even, you make it odd, automatically your whole calculation is going to be wrong. So you don't want to do that. And sketching is not that hard. It's just a very simple process. So make sure you do that correctly. Okay, let me give you the idea on how do we sketch for periodic function. So the idea of sketching for periodic function will be copy and paste. So let me put a remark over here. So the idea is copy and paste. So what do I mean by copy and paste? So let's say, let me draw the axis first. Okay, let's say if I have something like this. Okay, and what happened is that the primary shape is going to look somewhat like this. Okay, so let's say that is going to be the primary shape. How do we get the primary shape? So that will be from the function given in the question. So don't worry about that. So later I'm going to show you a bunch of examples. So basically it's just from the question given. Okay, copy. Okay, so this is what I mean by copy. Okay, let's say this is going to be my primary function. So let me delete this one. Okay, so if I wanted to, and let's put values as well. So let's say here is going to be -1, so negative pi until pi. Okay, so meaning that one cycle, so that is going to be a period of 2 pi. So what if I wanted another cycle? So the other cycle, it could be on the left, it could also be on the right. But the thing is that the shape is going to be exactly the same as this. So that is what I'm going to do is, as I told you before, the idea is going to be copy and paste. So you're going to have exactly the same shape, but now it's going to be on another 2 pi units distance. So if it starts at pi, and of course after 2 pi distance, so the outcome is going to equal 3 pi. Or if I have another cycle, so it's going to be the same shape again. So it's going to be on this side, and it's going to cover from 3 pi until 5 pi. Okay, so this is going to be until 5 pi. Right, so the idea is going to be copy and paste. Of course, I'm using my iPad over here in order to do this. So that is why I can copy and paste. But when we do it by hand, so the idea is going to be still copy and paste. All right. Okay, I'm going to show you some examples here. So this is going to be my examples. So I've been using this example in class for quite some time. So we're going to start with the first one. So this is going to be my periodic function. Okay, so this is an example of periodic function. Well, I completely forgotten about that. First, I have to explain to you how does periodic function looks like. Okay, remember previously this is called as a piecewise function. So piecewise function means it's going to be separated like a different function at different values of t. So the idea of periodic function is going to be similar. It could be in terms of one function that looks like this, or it could also be in terms of a piecewise function, but commonly it is most commonly in terms of a piecewise function. So how do we tell if that function is just a piecewise function or is it going to be a periodic function? So that will be a difference. Okay, for example, let's say if I were to copy this, so I'm going to write that. So I'm going to make it as similar as the top. So f of t is going to equal 3 plus 1 from -1 to 0. And it's going to equal 1 from 0 until 1. So if I leave it until here, then this is going to be the same as previously. It is going to be a piecewise function. However, if it's a period function, I have to add an extra information. So what is the extra information? It's going to be this. I have to write that f of t is going to equal f of t plus 2. So what is this extra information over here? Okay, so basically the top part is going to give you the shape of the primary function. So how does one cycle looks like? So it's going to be given by the first function given. And the second function, what we're going to do is they're going to give you the value of the period, because you have to know the value of the period, then only you can start your calculation and then only you can start sketching. Alright, so how do the value of the period is given? Okay, basically this is going to be the general form. So the general form is f of t is equal f of t plus capital T. Okay, so this is going to be the general form. Okay, so basically, so whatever that is given at the back, this value right here, so that is going to be your value of the period. So periodic function, this is how it's going to be given. You're going to be given two functions. First is going to be in terms of the shape. Second is going to be in terms of a period. Or it doesn't necessarily be in terms of a piecewise function. So it could also be in terms of some simple function. For example, I can see that. So f of t is going to equal, so it's going to be f of t is going to equal t from -pi until pi. Right, so this, of course, the first one is going to give you information about the shape. From this one, you're going to determine whether your function is even, odd, or neither. Okay, and then if it's a periodic function, so there will be extra information given that f of t is going to equal f of t plus 2 pi for this case. And straight away we know that what is going to be the period value for this one. So the period value is going to equal 2 pi. Because this is the general form. So whatever value that goes before the closing bracket, so that is going to be your value of period. In terms of notation, so this is how periodic function is being written. Okay, now let's get back